Okay, so in this video we're going to talk about how to wire some of the circuits in Lab 2. And this is the first circuit that we want to wire, the series circuit. We're going to be looking into KVL and KCL in this lab. And whenever I'm trying to wire circuits, I'm not going to actually do this on camera with the breadboards and everything, but I'm going to use a program called fritzing, which will let us have kind of a what looks like a breadboard there, and I'll be able to show you how things go here. So we've got this 9-volt DC here, and then the way you're going to need to set this on your power supply, of course, is to set it using the variable output and controlling the little knobs there. You can use the digital display on it. I often just measure it with my multimeter to make sure I get close to 9 volts. And you don't need to have exactly 9 volts as long as you record what the measurements are. Obviously, you want to be close. And then you've got the 3 different resistors that you're connecting up. Now, before wiring a circuit, what I like to do is identify the nodes that we have here, because that's going to really tell us how many different rows or columns, depending on your perspective that you have the breadboard, that you're going to need to use to connect up the components. So I've got a node here, because remember, a node is a connection of 2 circuit elements, 2 or more, I should say. Whoops. I don't need that. Go away, go away. All right. And then here is another node, of course. Here's a third node. And then, of course, we've got one node down here. Sometimes people forget the ground node or the bottom node, but we have 4 different nodes in this circuit. All right, so I'm going to have 4 different connection points, or 4 different rows I'm going to need to use. Now, if we go to the fritzing here, the way the breadboard is, and I tried rotating it, but once I rotate it, all of the grid stuff just goes out of whack. And so I'm just going to leave it as is here for us, so that we don't have those issues. So first off, what I tend to like to do here is, your perspective from this video is that these are columns, but I often refer to what I'm currently highlighting my mouse over, and I just put a wire down. I refer to these as rows. And then I refer to what is actually, because again, of the perspective of the video here, these long rows here, I actually refer to these as columns. And again, to kind of remember what's going on here is all these pins are connected underneath. So I drew a wire there, but they're already connected underneath. So when we pop 2 things in there, that means they've made a connection. So we've got 4 nodes. So we're going to need, and I'll just, for instance, draw 4 things here. We're going to need to use 4 of these. And it doesn't matter which 4 you use. I'm just picking 4 random ones. So we'd use 4 of these to make our connections and connecting up all the components. So I'm going to, again, take those away because it doesn't really matter where. But what I am going to do here is I am going to draw a wire off to the side here. And actually, let me kind of do that again here. That's kind of something that's neat about this program here. Fritzing is now I'm holding in this wire, and what's yellow, it's basically saying everything connected to this wire is also connected to those yellow holes. So everything is connected to that yellow hole there. And so I'm going to change the color of this because I want these to be a little bit more reflective of what we would be doing here. So that would be a red wire that we'd, for instance, put on the positive side of our 9 volts. And then if we draw another wire here, and again, it's showing all of the things that it's connected to there. And I would make this one a black wire. And that would be connected to the negative side of the power supply. Okay, so now it's time to start putting in some resistors here. And I'm going to go ahead and plop a resistor down here. And I'm going to go ahead, and what I've done here is I've just dragged the legs of the resistor and made them longer. And what's kind of neat again here is there's these little green highlights showing, okay, these are kind of being connected together. And actually, let me go ahead and maybe move it one like that. Now I'm going to go ahead and make this the correct value. So we said we had 1 ohm resistor here. And then it does the correct color band for you. So 1 ohm is brown, black, red, and then it's a 5 tolerance, so it's gold. Now if we go back to the diagram here, we can see that one node here is the 1 kilo ohm resistor being connected to the 9 volt power supply. So what I'm going to do here is I'm going to run a wire, and I'll make that wire, because anytime I'm connecting up to power, I like to make it red. So I've now connected I've connected the one side of that 1 kilo ohm resistor up to the 9 volts. Now technically we could just have moved this leg of the resistor straight to the power rail, but I often don't like to do that. I find that having too many wires in the power rail or components in there, you have problems of them popping out and other things like that. I like to wire the power up separately. All right, now let's look at what is the other side of the 1 kilo ohm connected to. Well, the other side is connected to a 2.2K. Okay, so I take another resistor here, and I'll fix the value in a second, but it's, whoops, wrong spot. There we go. And I'm going to go ahead and make the one leg just longer here, so again I can kind of, I'll make the other side longer too. Now this is supposed to be a 2.2K, so let's get the color band up correctly. And now we can see that because they're in this same here, the green here, these two wires of these two resistors are now connected to each other because they're in the same, well, depending on your perspective, column, but again, I like to call these rows here because I always like to have my breadboard when I'm wiring rotated 90 degrees. That's just my preference. There's no right or wrong reason to that. It's just preference. Okay, now if I go back to my circuit diagram, well, the other end of the 2.2K is connected to a 4.7K. All right, so then I need another resistor, and I'll just plop it down here for now. I'll fix the value, it's 4.7K. And then I'm going to just, again, just to make the, whoops, I just drew a wire. Come on, stop it. Man, my pen is just not wanting to work with me right now. I can't get this here in just a second. There we go. So I'm just drawing again the legs a little bit longer on the resistor. And this is when you bend your resistor leads, you can make them, you know, as spread apart or as narrow together as you want. Sometimes spreading them apart like this makes it a little bit easier to take the measurements because you can almost lay them somewhat flat on the breadboard. But sometimes you don't have, you're putting so many things on the board that you don't have space to do that. And so now this 4.7 is connected to the 2.2K. And again, we can see that the color band matches correctly. Now I go back to my circuit diagram, and I go back to here, and I can see that, well, the other end of the 4.7K is connected to the negative side of the power supply. So I'm just going to run a wire to the negative side of my power supply, which I will make that black then to indicate that it's going there. Now this is where you have to be very careful. It's very easy, and sometimes people, what they'll do, just to show you, sometimes what people will do is they'll move, whoops, that's just inserting a thing. They'll actually, instead of having the red wire over here, they'll put the red wire clear on the other side of the board so they don't run into the chance of mixing up power and ground. But as long as you're careful, you can run them in the same side of the board like this, and sometimes you have to, because if you have multiple voltages, You don't really have much of a choice. And so this would be a way to wire up that circuit. Now, the other circuit in there, and as a side note here, there's another thing that I was taught when I was in college, that every time, I don't necessarily do it anymore, but every time you make a wire connection, you cross it out. So when we made this first connection here, this red wire here, I should cross out this wire right here because I just connected it. And then when I connected the 1K to the 2.2K, when I did this connection here, I should go back to my diagram and cross off this wire. And that way, you know, if we do that, we cross off all the wires eventually, and then we know we've wired up the circuit correctly. All right, so there's one more circuit here that we want to look at in this lab. So let's look at this pretty quickly. This one's actually it's a parallel circuit, and we're using the same value of the resistors, except now we're connecting them in parallel. Which again, as a side note, is how like your outlets are connected. Sometimes people refer to this as daisy chaining them, but it's really parallel. So what I'm going to do here is I'm going to go ahead and delete, actually, instead of deleting those resistors, I'll just move them here because they're the correct value already. And my program crashed. So let me pause and start it back up. Alright, so I got the program restarted here. This is, I mean, it's a great program, but it crashes a lot, which is why I don't use it a ton. But what I have here is this is kind of just what we had before. The 1K ohm resistor, my 2.2K ohm resistor, my 4.7K, and then I've deleted the wires that we connected up to the circuit. So this is still going to my 9-volt power supply and my negative. Of course, remembering you should always wire circuits with the power off. So if we go to, that's not what I wanted to go to. I want to go to the diagram here. There's actually two ways, well, there's several ways, but there's two primary ways you could wire this circuit up, and I'll show you both. First, we should count the number of nodes. Well, remember this at the top here, this whole thing is just one node because it's a connection point of at least two or more components, but all of these things are connected to the top node, and all of these things are connected to the bottom node. So technically, we only need two rows or columns to connect everything up. So let's go back to the fritzing and see how we could breadboard this. So we could breadboard this by simply moving, oops, that's a wire. The components like this, putting all the resistors. Now notice that all three of these resistors are in the same, again, I like to call these rows. And so the top ends are connected, the bottom ends are connected, and of course it doesn't matter what way you put in a resistor. There's no top end to a resistor in reality. I mean, the way the fritzing has done it, all the gold bands are lining up, but that's irrelevant. You don't need to have that. And then if I want to connect this up, well, I would connect the one side up to power, and of course I'll go ahead and change that to red. And then the other side, we connect up to ground, or the negative side of the power supply, which is black. And so then that would be all of it. And again, if we're trying to do the cross off thing here, when I connected that red wire up, I've crossed off this right here, but that's really just one connection. The same thing down here because these are all connected together. Now, the problem with this here, and if you did this building your circuit, you could still, that'd be okay, but measuring all the voltages across each resistor would be a little bit frustrating to do, honestly. It'd be a little tedious to do, to try and touch the probes against each of those resistors and make sure, you know, and you might say, oh, well, what if the resistor wires touch? And that's actually fine because it doesn't matter if these resistor wires on the bottom side here touch or the left side because they're all connected together anyway. But to make things maybe a little bit easier for measurements, if you're wanting to do something a little bit different, let's delete that black wire out. And what I'm going to do here is I'm actually going to not put them in the same rows at all. I'm going to just have the three resistors lying down here. And I have all of them, you know, laid out here. Now let's look at here, back of this diagram here. All of the top of these resistors are connected to the power. All the bottoms are connected to ground. So what I could do here is have these resistors laid out like this, and then, whoops, I'm wanting to draw a wire, not so I could do a connection in like that. And now suddenly the left side or the bottom side of all those resistors is now connected to ground, or the negative side. They're all connected to the same thing. And then I could do the same thing here, and I'll change this to a red color. And we can do this with all of the resistors, and that's in the wrong spot. So let me put that here. And now these are still wired in parallel because let's look at the pathways of how things are connected here. And I'm going to just kind of draw my, so this is connected to, this top was connected to 9 volts. This top is also connected to 9 volts. So if this top is connected to 9 volts and this top is connected to 9 volts, then these two tops are obviously connected together because they're connected to the same thing. Also, finally, down here, we've got another 9-volt one here, and that's connected. So all of the tops of these resistors, or the right side of these resistors, are connected to the same thing. And then we have the same thing with the grounds. So the only reason this is maybe slightly better is then I can look at just touching my probes across one resistor at a time much easier. The problem with wiring up like this is it takes up a lot of space on your breadboard. And when you get into more complicated circuits, this is taking up valuable space that might be used by other chips or components. But for a simple circuit, this works out great.